Welcome to your first step in Python programming. We start with the print function, which sends text to your screen so you can see what your code is doing. Notice how we wrap our text in quotation marks to tell Python this is a string of characters. A common mistake for beginners is forgetting these quotes, which leads to a name error. Let's try it out with a simple greeting. Python works like a powerful calculator using standard math operators. We use the plus sign for addition and the asterisk for multiplication. You can combine these in a single line, and Python follows the standard order of operations, doing multiplication before addition. Be careful not to use an X for multiplication, as Python only recognizes the asterisk. Watch how we calculate a simple total here. When we use the / for division, Python always returns a float, which is a number with a decimal point. Even if the result is a whole number, like 10 divided by 2, Python gives us 5.0. This ensures precision in scientific calculations. A common point of confusion is expecting an integer back when the division is even. Let's see this decimal behavior in action. Sometimes you don't want a decimal, you just want the whole number of times one value fits into another. For this, we use the / operator, known as floor division. This effectively chops off the decimal part entirely rather than rounding it. Beginners often confuse this with standard division, but it is essential for tasks like calculating index positions. Here is the difference visualized. The % sign in Python is the modulo operator, which gives us the remainder of a division. This is incredibly useful for checking if a number is even or odd by seeing if the remainder is 0 when dividing by 2. A frequent mistake is thinking this performs a percentage calculation, but in Python it is strictly for remainders. Let's find the remainder of 10 divided by 3.
To raise a number to a power, we use 2 asterisks, which is the exponentiation operator. For example, 2 to the power of 3 means 2 multiplied by itself 3 times. Many learners mistakenly try to use the caret symbol for math class, but that performs a bitwise operation in Python instead. Let's calculate 2 cubed to see the result. Variables are like labeled boxes that store data so we can reuse it later. We create one by choosing a name and using the equal sign to assign a value. It is best practice to use descriptive, lowercase names separated by underscores. Avoid starting variable names with numbers, as Python will throw a syntax error. Let's store a price and print it out. Python is dynamically typed, meaning a variable can hold an integer and then be changed to a string later. You don't need to declare the type of data beforehand, which makes the language very flexible. However, be careful not to confuse your types when performing math, as you cannot add a string to an integer. Let's see a variable change from a number to text. We can join 2 strings together using the plus sign, a process called concatenation. This allows us to build dynamic messages by combining static text with variable content. A common error is trying to concatenate a string with a number directly, which causes a type error. To fix this, we must ensure both pieces are strings. Let's combine a greeting and a name. To make our programs interactive, we use the input function to get data from the user. The text inside the parentheses acts as a prompt for the person typing. Crucially, the input function always returns the data as a string, regardless of what the user types. This is a major trap for beginners who try to do math with input immediately. Let's capture a user's name. Since input always gives us a string, we use typecasting to convert that data into an integer or float. By wrapping input function inside intent, we tell Python to treat the text as a whole number. If the user types something that isn't a number, like a word, Python will crash with a value error. Let's convert a string input into a number we can add to.
Now we combine everything: input, typecasting, variables, and math. We will ask for a birth year, convert it to an integer, and subtract it from the current year to find the age. Notice how we use a comma in the print function to handle different data types automatically. This is a cleaner alternative to concatenation when mixing strings and numbers. Let's run our final basic calculator.